let's look at the question first. So an ideal, they have given you an ideal mixture of ethane and ethene. All right, occupies 28 liters at 1 ATP and 273 Kelvin. So in the question they have given you the volume, which is 288 liters. They have given you the pressure, which is 1 atm, and they have given you the temperature, which is 273 Kelvin. Now the mixture reacts with 128 grams O2 to produce CO2 and H2O. You need to figure out what is the mole fraction of C2H4 in the mixture. Alright. So, okay, now we need to first write the reaction. So any hydrocarbon, when it reacts with O2, it forms CO2 and H2O. So C2H6 plus O2 will form CO2 plus H2O. And the same way, C2H4 plus O2 will form CO2 plus H2O. Alright. Now let's balance these reactions. Okay. So carbon is balanced. Then let's balance hydrogen. Now let's balance oxygen. So 4. Okay, so here it is 2 into 2, 4 plus 3, 7. So here will be 7 by 2. Right. So here also I'll balance it once. 2, then 2. So I have 4 oxygen and 2 oxygen, total 6 here. So it will be 3 here. Alright, so I think it's balanced at the moment. So the mixture reacts completely with 128 grams of O2 to produce CO2 and H2O. So what they've given me is the total weight of O2. So they've given me the total weight of the mixture basically. Total weight of O2 has been given, which is I think 128 grams. Alright, now I need to figure out mole fraction of C2H4 in the mixture. Okay, so it's a very standard mole concept question. Okay, it's mixed with a little bit of gaseous state as well. So what I'm going to do is I'm going to first find out the total moles, because in the initial part of the reaction they've given you ethane and ethene occupying 28 liters at 1 atm pressure and 273 Kelvin. So I can actually find out the moles of the mixture. The moles of the mixture will be equal to, total moles basically will be equal to 28 upon 22.4. The reason I'm directly using 22.4 is because they have been given STP, standard pressure and temperature has been given, so I can directly use 22.4. So so there is a total moles I have got, which is 28 upon 22.4. Now if I am able to find the moles of either of the gases, I can find the mole fraction of C2H4. Alright, so okay, now let's do one thing. Now let's calculate the total moles of O2. Total moles of O2 will be 128 divided by 32. So it will be I think 4 moles. Okay, so we have 4 moles of O2 reacting with C2H6 and C2H4. Now we can consider that some X moles are reacting in the first reaction and 4 minus X moles are reacting in the second reaction. Alright, okay. So I can say that if X moles of O2 reacts, how many moles of C2H6 will form? Now let's try to calculate that. Moles of O2 divided by 3.5 basically will be equal to moles of C2H6 divided by 1. Okay, so moles of C2H6 can be written as 4 upon X upon, it's X upon 3.5, which is the moles of C2H6. Alright, now let's write the moles of I can write a similar reaction where moles of O2 by 3 will be equal to moles of C2H4 by 1. Alright, so the moles of O2 will be in this particular is 4 minus x upon 3 will be equal to moles of C2H4. So we have got the moles of C2H4 also in terms of x. The total moles of these two is 4 minus x upon 3 plus x upon 3.5 will be equal to it will come out to be 28 upon 22.4. So from this equation you can calculate x. Alright, and you can also find out the mole fraction, because let's just say if I ask you the mole fraction of C2H4, it will be x divided by the total moles, which is 28 upon let's just call it y, because it's difficult to write it. Yeah, so the mole fraction of X2H4 will be x upon y. Alright, so this is how you're going to approach this question. I hope you find this video helpful.